Hello guys, and welcome to this video. We're going to learn how to create a neuron, which is the foundation of a neural network. By the way, a neural network is uh, it is basically an artificial brain. um, Things like ChatGPT and all of these things are neural networks of some kind. So I'm going to get into the foundation, the detail, the beginning of how these things came about. And we are going to start with building just one neuron, which is a simple mathematical function that processes things and uh, recognizes patterns. So let's just jump straight into it. First of all, we are going to need two main um, modules within Python. So you don't need at first you don't need any pip install. So we're going to go and create the neuron. I like doing um, object-oriented stuff. So um, I would like to see the neuron as an object which I can instance at any time, uh, more than I would like to just write the formula like that, which is hard to understand. So we are going to start by initializing things called weights. I'll explain that shortly. So here we're going to say self.weights. Now these weights are the things that in our input, um, our inputs are all going to be assigned and multiplied by these weights. Okay, this is what the neuron does. It sees a bunch of numbers and it assigns, or let's say it multiplies the weights by the values that you give it. So for example, you have a data set, okay, which you are going to train it on. Okay, you're going to train this data set. Let's break down the data set. The data set is going to be a mapping of x to y. Okay, according to the explanations I've heard, it is going to be a mapping of x to y, where x is going to be your list of inputs, however much inputs you have to pass into this neuron. We'll get to how you do that in a second. So here we are going to have our list of inputs, which could be any number, any set of numbers. Okay, but the length of these numbers, it matters a lot because it is going to be expected by your neuron, which is why here I'm going to add the number of inputs so that the neuron is going to generate a random number of weights so that it makes it makes a random number of weights to multiply with the each of what's in x. So here we're going to have a list that is going to be generated randomly. So we are going to say random.uniform -1 to 1 for underscore in a range of the number of inputs, which we have expected it here based on our data set to be x, to be 4. Okay, so we are going to say num inputs here like that. I don't know why Pylance is crashing. Anyway, so there is another thing called the bias. By the way, as I'm saying it right now, I'm actually learning it. I don't have, I don't really know what's still going on. I just know that it's mathematical functions and what's not. Um, so I don't have like much knowledge about it. So y is it's going to be our label, the thing that when the neuron sees this kind of list, it knows what to expect. So y is the label that is assigned to this one, this x. typically you would not put x and y separately like this. Say for example, this is if you want to, for example, build a weather forecasting neuron, for example, it's just an example. You have features of what makes rain more likely to fall. You have things like temperature, you have things like humidity, you have things like air pressure or something like that, and whether it rained last week or not. And then the computer is supposed to predict, will it rain or not? Will it rain or not? So based on these inputs, this is our x. So if we break it down even further, we can say t, h, p, like this, and then it will predict whether will it rain or not. So our data set is supposed to be this clean. It is supposed to be this structured. We should have about a minimum of 10 or 100,000 of these inputs together with their mapping of whether it actually rained or not. So how you collect the data doesn't really matter right now. We are going to build a custom one uh, in the subsequent videos if this one is too long. We had 7 minutes. Okay. Uh, so here we go. But if you pass these letters, there's nothing that the neuron can understand because it's a mathematical function. It's going to be doing calculations, and so it would not recognize what these things are. So we have to turn these values into numbers. The temperature of a certain date, for example, is 200. The wait, 200? There's nothing like that. 200 what? Maybe 30 degrees. You have humidity of, we will just do random numbers. And then we would have whether it rained or not, which can be 1 or 0. Okay, so we are gathering data based on real life um, occurrences, if, if you get what I mean. So here we are having this structure, number, and then is equal to output. But here we are going to transform this into a Python way of doing it, and we have to put these things inside a list. We have to make this temperature, humidity, and pressure into a list. So we are going to say 30, 40, comma 30, like this, and then equal to 0, which is impossible to do in Python. So we have to Pythonize it by saying 30, 40, 30, and then we just put a comma, and then we have 0. Now this is going to be the mapping, the way we map x to y using Python. Okay, so we typically then put all of this back inside a bigger list, and then we would have like 100,000 of these, okay, followed by commas. We go over and over and over again, and then, you know, stating reality based on what we want the um, model to learn. When the model sees this kind of list, it knows that what will follow is that it actually rained when the pressure was 50, and it did not rain when the pressure was 30. You get what I mean? So it has to see a lot of this, which is why AI is a very demanding thing. It needs a lot of data, like crazy loads of data. Like the more the better. In this particular case, the more the better. It's not less is more in this case. It is more is more. Okay. So this is how we map it, x to y. okay, because this list is X and then the label is Y. The answer is Y. This is what we expect the model to generate when we give it our inputs. So here we are going to reduce the number, and then we are going to use this um dummy data set. We're going to uncomment it because we don't have time. Control slash. Then we're going to put this in a list. So this list is going to be our data set. There's no beautification. I hate it when it doesn't do that for me. So I have to press tab and beautify it myself. Anyway, so here we can delete the X and Y and we can continue. Now we have a data set. Actually, let us randomize it. Let's say when the temperature is also 40, it is more likely, or let's say when it reduces, because it's not realistic, 20, then it is more likely to rain. Yeah, so the bias is only one number, and okay, so the bias is just one number. The bias is just going to be one number because it is just one neuron, and each neuron has its own one bias, but the weights have to be assigned to the inputs. So yeah, that's just how they designed it. I don't know why. That's just how it seems to work. Random dot random like this, which will give us a float. Oops, which will give us a float. So now we are going to move into something called the prediction function. Here we are going to tell the neuron to calculate, to do the required calculations in order to produce a prediction, in order to produce an answer for us based on what we feed it, which is going to be our X, as we have here. So this is also called the forwarding function. If you want, you can call it predict or forward or feed forward if you like, but I'm going to call it predict to keep it self-explanatory. So we go this way, we go predict, we go it's relatively easy. Normally we would use a module called numpy, but I don't want to do that because we are going to do the calculation by ourselves. So the formula is very simple. It's wx plus b, where w is the number of weights. Each weight is multiplied by x, as I said earlier. That's why we have to have this to be correct all the time. This number should be correct because each one will be multiplied, each random weight will be multiplied by each of these numbers. So it has to be correct. So, and then at the end of this calculation, we add the bias, which we have here, which can be a random number. The reason why it is random is so that it's actually, you can put any number that you want, but based on the data that is passed through it during training, then while it is training, the weights and biases are going to be changing, and so it doesn't really matter what it starts with because it is going to change in the end based on your data. That's what makes it very interesting, because you are not telling it what to do. It is figuring it out based on these calculations and based on how clean your data is, and also, you know, other factors which I don't know of right now. So to do this in a Pythonic way, we just have w, which is self.weights. For each of these self.weights, um, let us play with this a little bit. Let us say total is equal to a new list of the assignments. We're going to say um, we're going to do a for loop for weight in self.weights. I'm going to say for each of the weights in self.weights, we are going to have each weight should be, and also for each of the x's. Hey, wait, get it? Um, so for each of the weights, it's quite confusing how to do it using a for loop, because actually let us zip it. Okay, for w and x in zip, okay, zip of self.weights, which would make total sense because it is going to zip it. It is going to assign index 1 to index 1 of x, index 1 of weight to index 1, index 2 of weights to index 2 of x. That is why it has to be, it is just like a zip. You are assigning left to right, left to right, left to right. So this has to correspond. Self.weight has to come first. That is why w is first here. Take note. So we have x. We're going to put x here, but let us name it to inputs here, inputs, so that our variables don't clash. So we go for w. Here is very simple. We just do this w times x. Boom. That is it. Total equals to this. And then at the end of the entire thing, we do total plus equals self.bias. Simple. But there's a shorter way of doing this. There's a shorter way of doing this. We don't have to do this on 2 lines. We can do it inside one simple list. So let's rewrite this inside a simple list. We go not total, but let's say g just as a placeholder. We go this way. W times x for w comma x in. We copy this and we paste it here for the zip. And here we have it, a list of the multiplied values. Those multiplied values will then be summed. Will they be summed? If I can remember correctly, they were summed here in my note, because we have self.output. We have to dot it first. They used numpy here. They used numpy in this scenario. I don't want them to use numpy. Okay, sorry for wasting your time, but I need to check this math. Okay,